Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. So in my lecture series today, we're going to see about the ER model under the conceptual data modeling. So I'm going to, before dealing with the ER diagram, so first we're going to see about the introduction to the ER diagram. So main thing is, as a database architecture, design phase is very much important. So in the design phases, it can be classified into three different stages: initial stage, second stage, and the final stage or the end stage. So in initial stage, we have to gather the data from the user. So as a programmer, as a database architect, from the technical side, we have to we have to get a requirement from the user. Based on the requirement only, our technical team can to develop a project to them. So before going to the database design, first we have to get the input from the user. And also, as a user, maybe as a database architecture, we're going to collect the data based on the perspective of the database user. In the second phases, we're going to, based on the user input, we have to create a data model. So your data model may be a ER model, or you can use relationship data model, or by using an XML you can use, or network model, hierarchical model. So based on the needs and the visualization technique can be chosen by the user, and also maybe the customer specification. In my last stage, based on the diagram, that is a graphical representation, we have to implement the database. While implementing the database, it can be classified into two types. One is a logical design, another one is a physical design. So physical design, just layout of the database, can we call it as the physical design. In logical design, it based on the schema. Under the schema, what type of attribute we're going to use, what is the size of attribute, what are the attributes are required, what are the entities are required, is there any redundancy, is any incompleteness in the thing, everything we're going to decide in a logical design. So while designing as a database architect, while designing a database, definitely they have to keep it in this thing. So it will be having a three phases, and also while implementing the database, definitely we have to consider the logical design as well as the physical design. And also I have teach you in the previous slide itself. So your schema must be a physical data independence. If you do any changes in the physical database, that should not be affected to your logical database. That to be considered while designing a database. So this is a major thing to be considered while designing a database. So after designing a database, we have to go for these three things. One is we have to choose the appropriate data model. So based on the appropriate data model, diagrammatic expression, we're going to convert it into a mathematical operation. That is a representation of a data model. After representing, what type of a query language can be used, that would be deal with the physical data model. So always our data model can be classified into these three stages. Let us see one by one. So first one is the conceptual data modeling. So conceptual data modeling is nothing but the initial phase. We have to understand the problem statement. Based on the problem statement, we have to gather the information from the user. So based on their requirement only, we're going to create a database. So first we have to gathering the requirement from the user before designing the database, before starting the database or designing the database. And also we have to use any one of the model to represent our database. Usually in all the field, they are using only two models in a real world industry side and all. They can go for a relational data model, or we're going to use the entity relationship model. So in my upcoming slide and all, I'm going to use only a ER model, but that is a thing in your syllabus. So I'm going to consider that particular thing in my upcoming slide also. So we're going to choose the entity relationship model. So we are choose the entity relationship. What do you mean by entity relationship model? So it is nothing but the high level database design. And also by using that particular design, we can able to define our data. And also we're going to represent the relationship between the data. For that only we are choosing an ER diagram. So in the name itself, we can able to classify the thing that will have entities. Each and entity relationship, we're going to mention it over there. So that particular concept only we can call it as a entity relationship diagram. So we will see it later. What do you mean by ER? What type of symbols can be used? Notations, everything we can discuss in my later slide. So we are choosing an ER model. So here we are having a main three components are there. One is an entity, attributes, and their relationship. Entity is nothing but the all real world object, we can call it as an entity. It can be represented in a rectangle in a ER diagram. The next one, attribute. Attribute is nothing but the description to the entity. We can call it as an attribute. It can be represented as an oval shape. And also attribute can have a different types of that. We will see it in the upcoming slide. So, and also we are having entity, we are having an attribute. The third component is a relationship. So it can be defined, it can be represented in a ER diagram as a rhombus or a diamond shape. So this is nothing but we're going to mention the relationship between the two entities. So we are saying it is a relational database model. Definitely we are having a database contains so many tables. So we have to connect the each and every table together. For example, if you are taking a student database management system, student is my entity, another one is a internal mark or a final result is another entity. So I have to connect these two things. Is it right? So student must have a result. Is it right? Must have is a relationship established between the student and the mark entity. So this is the relationship. This has been mentioned as a diamond or a Roman shape. These are the three major components. The next thing is second type of a thing in data model is a representation. How we can represent this particular ER diagram in a mathematical way means for that we are using the relational algebra or relational calculus by using an operator, normal operator. For example, unary, binary and derived operator, we going to represent it in mathematical relation. So for your creating, we are going to use the project operator. Selection, we have used the dow, and rename operator is a pi. So, and also we are having a union, cross product, minus, set difference. These are the join operator. And also we are having a cross join, and also we are having a relational arithmetic operator and the relational operator. These are the derived from the unary and the binary operator. By using this thing, we're going to convert our database structure, that is a physical structure, to the mathematical representation by using a relational algebra. The last one is a physical data model. So what do you mean by physical data model? Means we constructed the ER diagram. Based on the ER diagram, we have represented the relational algebra. So how we can retrieve the data? Is it right? We're going to get the data. Whatever we are requesting, that we have to get it as an output. That could be done by using a structured query language. Or you can go for NoSQL. It is a schema-oriented architecture. If you want schema-less architecture, you can go for a non-SQL and the new SQL. So by using any one of the query language, we're going to practically implement our relational algebra. That is, we are converting our mathematical mathematical expression to a practical implementation. For that only we are using a structured query language. So normally, as a database architect, they have to consider these three things. Definitely they have to face this three stages. Then only we can able to create a perfect database to the user based on their requirement. So in my next session, I'm going to detailedly explain about the ER diagram along with the example. Thank you for watching my video.